Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits and continuity, right? And here we have to discuss the continuity of the function which is f of x is equal to mod of sine x plus cos x at x is equal to pi, right? So in this lecture we'll see how to show that this function f of x is continuous at x is equal to pi, right? Okay, now see, this problem can be solved by two methods, right? So the first method is the method of using the concept of composition of functions, right? But here I will not use that method, and I will prefer the usual method of proving the continuity of functions by finding out the left hand limit, the right hand limit, and the value of the function at that point, right? So let us start. Now see, from the definition of continuity of a function, we know that if we are given a function, say y is equal to f of x, which is defined in some domain D, then this function is said to be continuous at some point A if the left hand limit exists and the right hand limit exists and both the limits are equal, along with the value of the function at that point, right? So if this condition is satisfied, that is the left hand limit is equal to right hand limit and both the limits are equal to the value of the function at the given point, then the function is said to be continuous, right? So here we'll first find left hand limit, then right hand limit, and then f of a, right? So here a is pi, right? So let us first find out the value of the function at this point pi. So we have f of pi is equal to mod of sine pi plus cos of pi, and we know that sine pi is 0, cosine pi is minus 1, so we have mod of minus 1, that is equal to 1, right? So f of pi is equal to 1, right? Now let us find out the right hand limit and left hand limit. Now before finding out the right hand limit and the left hand limit, let us make some changes in the given function, right? So f of x can be written as mod of, here we can write square root of 2, and here we can write 1 over square root of 2 sine x plus here we can write 1 over square root of 2 and cosine x, right? So what we have done, we have multiplied sine x plus cos x by square root of 2 and divide it by square root of 2, right? So now we can write square root of 2. Now here we can write 1 over square root of 2 as cos pi by 4, and here we have sine x, and 1 over root 2 can be written as sine pi by 4, and here we have cos of x, right? Okay, so now we can easily see that this expression is equivalent to sine a cos b plus cos a sine b, right? And this is equal to sine a plus b, right? So here we can take x as a and pi by 4 as b, and this is b and this is a, right? So we have the well-known result from trigonometry. So sine a plus b is equal to sine a cos b plus cos a sine b. So now we can write this expression using this result as sine of x plus pi by 4, right? Okay, so now we have f of x is equal to mod of square root of 2 sine x plus pi by 4. Now let us take root 2 out of the mod function symbol. So we can write square root of 2, and here we have mod of sine x plus pi by 4, right? So we have now f of x is equal to square root of 2 and mod of sine x plus pi by 4, right? So now let us find out the right hand limit. So the notation for right hand limit is limit x tends to pi positive, and here we have f of x. So we can now write x is equal to pi plus h, where h is a very small quantity and h is infinitesimally very small, and it is a positive quantity, and when x tends to pi, h tends to 0, right? So to find out the right hand limit, we'll take x is equal to pi plus h, right? So we have a limit h tends to 0. Now we'll express this right hand limit in terms of h, right? So RHL is equal to limit h tends to 0 f of pi plus h, right? So now the value of f of pi plus h can be obtained by taking x is equal to pi plus h in this expression. So we have limit h tends to 0. Here we have square root of 2 and mod of sine. Here we have pi plus h plus pi by 4, right? Okay, so now we can write limit h tends to 0. We can take this square root 2 outside the limit notation, and here we have mod of sine, and here we have pi plus pi by 4 plus h, right? So here what we have done, we have combined pi by 4 and h, right? So pi by 4 plus h, so that this term, if we take this term as theta, then we have sine pi plus theta inside the mod symbol, right? Mod function symbol, we have sine pi plus theta, right? And this angle pi plus theta, it lies in the third quadrant, right? So this lies in the third quadrant. And we know that sine pi plus theta is negative of sine theta, right? So now here we have square root of 2 limit h tends to 0, and here we have negative of sine of theta, right? Here we have assumed pi by 4 plus h as theta, and sine pi plus theta is minus of sine theta. So now we can write square root of 2 limit h tends to 0, and here we have negative of sine. Here we have pi by 4 plus h, right? Okay, so now this negative sign can be neglected here because this is inside the mod function symbol. So we have root 2, and we have simply limit h tends to 0 and mod of sine pi by 4 plus h, right? So here we have removed this negative sign because we know that mod of x times y is mod of x times mod of y, and here this negative sign can be taken as minus 1. So mod of minus 1 is simply 1, right? So here we have 1 times mod of sine pi by 4 plus h, right? So now here we have an important concept, right? See, here we have mod of sine pi by 4 plus h, and we know that h is infinitesimally very small, and when we add uh, h to pi by 4, right? So this angle pi by 4 plus h, this angle is less than pi by 2, right? So it means we are in the first quadrant, right? So when we are in the first quadrant, the sine function is positive, so we can now remove this sine of mod function here, right? So we have now square root of 2 limit h tends to 0, and we have sine pi by 4 plus h, right? because pi by 4 plus h angle, it lies in the first quadrant, right? So it lies between 0 and pi by 2, and sine function is positive in the first quadrant. So we can now remove the mod sign here, because here we have used the definition of mod function, that is mod of x is positive x whenever x is greater than 0, right? So sine of pi by 4 plus h is greater than 0, right? Sine pi by 4 plus h is greater than 0. So now we have a simple limit here. We can now take h is equal to 0 here. So we have sine pi by 4. So this is root 2 times sine pi by 4 is 1 over root 2. That is equal to 1, right? So the right hand limit is equal to 1. Now let us find out the left hand limit, right? So the notation for left hand limit is limit x tends to pi minus f of x, right? So this is the notation for left hand limit. So here we'll take x is equal to pi minus h, and again h is a very small quantity and it is positive, right? And when x tends to pi, h tends to 0, right? So the left hand limit can be written in terms of h as limit h tends to 0, and here we have f of pi minus h, right? So now we have limit h tends to 0. F of pi minus h can be obtained by taking x is equal to pi minus h in this function. So we have square root of 2 mod of sine x. For x we can now write pi minus h plus pi by 4, right? So now we can write this term as a limit h tends to 0, and we can take this root 2 outside the limit notation, and here we have mod of sine, and see here we can collect these two terms. So this expression can be written as pi plus pi by 4 minus h, right? Okay, and we can now take this angle as theta. So theta is pi by 4 minus h, right? So this expression becomes sine mod of sine pi plus theta, right? So we have got the same expression as we have got in the previous session, where we have obtained the value of the right hand limit. So now, as usual, sine pi plus theta is equal to minus sine theta, right? Because this angle pi plus theta lies in the third quadrant, right? So now we have square root of 2 limit h tends to 0. So we have mod of sine pi plus theta, and sine pi plus theta is negative of sine theta. So here we have minus of sine theta, right? And again we know that mod of xy is equal to mod of x times mod of y. So mod of minus sine theta can be written as mod of minus 1 times sine theta, that is equal to mod of minus 1 times mod of sine theta, that is equal to 1 times mod of sine theta, and that is equal to mod of sine theta, right? So here we have root 2 limit h tends to 0, and we have simply mod of sine theta, right? So now we can write the left hand limit as root 2, and we have limit h tends to 0 mod of sine pi by 4 minus h, right? And we know that again this angle pi by 4 minus h, it lies in the first quadrant, right? And in the first quadrant, the sine function is positive. So sine pi by 4 minus h is positive, right? So mod of sine pi by 4 minus h can be taken as sine of pi by 4 minus h, as we have done earlier, right? So using the definition of mod function, we can now write square root of 2 times limit h tends to 0, and we have sine of pi by 4 minus h, because sine pi by 4 minus h is positive, because pi by 4 minus h lies between 0 and pi by 2, right? So now we have root 2, and when we take h is equal to 0 here, we have sine pi by 4, that is equal to root 2 times 1 over root 2, that is 1, right? So the left hand limit is also equal to 1, right? So viewers, we can see that the right hand limit is equal to the left hand limit, and both these limits are equal to the value of the function at x is equal to pi, right? So the condition for continuity of a function is satisfied by this function at x is equal to pi, right? So this function is continuous at x is equal to pi.